Right, the 2012 external, question 2. You can pause and read the question. Have a read of it in front of you. Vice captain, the team is present at assembly 93% of the time that the captain is present. So the captain is present and the vice captain is present with a probability of 0.93. So the probability is not will be 0.07. Remember, our probabilities have to add to 1, which means we could fill in this one as well. And 75% of the time that the captain is absent. So when the captain's absent, the probability of the vice captain's there, 0.75, 0.25. Oops, a bit tricky. Okay, so let's try part 1. Try and keep the picture on the screen. Both the captain and the vice captain were present. 0.95 times 0.93, 0.8835, and just check it wanted a probability. So we captain present and the vice captain present. Moving along a branch, we multiply. Remember to multiply down the branches. Right, part 2. Calculate the probability that the award will be presented at least the captain or the vice captain is present. So one of them is present there, at least one, could be both. Captain is present there, vice captain is there, but this one would be the one where both are absent, so the prize won't be awarded. So there are 3 times the prize will be awarded. So in that situation where there's more than one branch, we can multiply down each of the 3 branches and add the answers together. Some of you might realise that you could also multiply down this last branch and subtract the answer from 1, because these 4 outcomes, if that's all that can happen, must add up to a total of 1. So 1 minus this bottom branch would work as well. But multiplying down the 3 branches and adding them up, we've done the first branch, which was 0.8835. Next branch, 0.95 times 0.07. And the next branch, add them all together and it should equal 0.9875, which if you do 1 minus 0.05 times 0.25 equals the same thing. So that's my answer for part 2, 0.9875. Right. Part 3, now I don't want to move the screen because I will lose my tree, and we'll just clear some of that away, so I hope you got all that. You can rewind the video if you missed some of those numbers. So let's think about part 3. You can read it in front of you. It says, if the vice captain of the hockey team is absent from assembly, there's a 40% chance that he's sick. So it sounds like we're adding another branch. Poor old vice captain is absent. He's either sick or he's not sick. It says there's a 40% chance he's sick. So we're not quite so sure what the other reason is, doesn't matter. And then part 3 says if the captain is absent, so that means we've gone this way. That's a given. If the captain is absent, what's the probability the vice captain will also be absent and not sick? The vice captain will be absent and not sick. So moving along those 2 branches, 0.25 times 0.6 gives me 0.15. That's for part 3 on the next page. We were told that the captain was absent, so we only needed to multiply these 2 branches together, not the 3rd one. Right, next question is to do with a power company. 12%, so straight away we can fill in this number. Probabilities have to add to 1. If a customer made a complaint, 0.7 chance that they left the company or stayed. And we don't know anything about this other branch at the moment, so we obviously don't need to. What proportion of customers complained and left? And in probability means to multiply. So the proportion that complained times the proportion that left, multiplying down the branch, 0.084. Right, part 2. We have a number. How many would be expected? So this is an expected value question. How many would be expected to complain but stay? So we need probability, and we'll multiply it by the 250,000. So we need the probability of complaining and staying with the company, which would be the top branch, 0.12 times 0.3, and then ultimately we'd multiply that by the probability. And if you work that out on a calculator, it gives you exactly 9,000 as my answer for part 2. Right, I don't want to lose the tree at this stage, but I might just erase some of these answers, so I hope you have written them down. We might need to use some of this working space for part 3. Right, so part 3 says the percentage of customers leaving over the last 12 months was 10%. Find the probability that a customer who didn't complain left the company. So that's the one we'll call P. We want the probability from question 3 that a customer who didn't complain left, which would make that 1 minus P. Now we know that over the last 12 months, the probability of someone leaving was 10%. So the way someone leaves, two branches, they either complain and leave, or they don't complain and they leave. So multiplying down this top branch, and I'm answering 0.3 here, not this question, would be 0.12 times 0.7 plus 0.88 times P, that branch, and altogether that has to equal 10% chance of someone leaving. So it's an equation to solve. You could jump into Solver right at the stage without doing anything else and work that out. Jumping onto Solver now should give you a value of P. Let's see if we can work that out. So we've got 0.084 plus 0.88 equals it's a bit hard to see there, 0.018 0.01819, I think it is. You have a look on your calculator. So we've found that value for P. Right, question 4. Once again, I don't want to lose my tree. We know what that number there is now. It's 0.01819, and that one will be 0.9818. So we'll erase this working down here again, and have a go at answering question 4. Last part of this question. It says, if a customer left Big Ben, what's the probability they complained? I can tell this is a conditional question. So if they left, what's the probability they complained? Now the part that we're given, which is the fact that they've left, always goes on the denominator. And the top line should be the probability of both things happening, complaining and that they left. So the probability of complaining and leaving, up the top, 0.12 times 0.7. We've done that plenty of times. Probability of leaving, we were told that from the question above, was 0.1. So working that out, we get 0.84 for an excellence. That's for part 4.